Hey, we introduced to you the program under EE1520 underscore participation. We have some challenge, but I hope most of us got it. I think there was one student who actually had a error, which is I completely have no idea how to solve that at that moment. But we will, I will help you if you, during the break, if you have that issue. So I want you to do one thing. I just want to repeat what we did last time. Let me first get my NG Rock running. Okay, I get my NG Rock running. Um, and then I'm going to run the server. I want to show you again what's going on, and it's important. Let me get to my server. I can kill this. Where is my server? So I will run my server. Wait a minute. I have to make again. If you haven't done this last time, this is the directory you need to download from the GitHub directory. And the things we did last time, we did the installation of JSON RPC CPP. If you haven't got that, you have to do that again. And we're going to do 2 times today, okay? And this is going to take your participation. So I'm going to run server. So the server is running. And then we have the client. I want to show you 3 cases. Okay, here is server. Okay, somebody already start getting in. But I'm going to tell you there is something which is we're going to do somewhat differently today. Here, I need to get back to here. So I'm going to run client. If I run client, everything looks fine. You're going to see this client. You have your name, your major. There is something called something. You see that this says already registered, meaning that this particular passcode is used last time. Because the last time we used the passcode something. So if you already have it, register once, it will not be counted. Okay, so you can submit the same thing multiple times, but I will only record your participation the first time. Okay, so you will see already registered. So what I'm going to do is I'm going to change the passcode for today. So every single class, I'm going to have a different passcode. So I have to decide which passcode I choose. So let's go to Yahoo News to see. I want to see the first news, the first piece of news, and then I will try to pick up the English word from the first word. I mean, we can have a multiple rule to do that. Let's go. Where do I get? Can I get rid of this? Okay, fine. Let's go to CNN. Let's go to CNN and I will click on this. Okay, so the first word I see here is Israel. Okay, so I'm going to change that to Israel, change the passcode to Israel. So this is what I did. I'm gonna change it every time we start a class. So I'm gonna change this code over here. I call the passcode secret. I'm gonna change to Israel. Do I spell it correctly? Let me see. Yeah, Israel. All lowercase. Okay, I don't use case sensitive. So my secret is Israel. And now I recompile my program, and then I'm going to run server. So now if I submit the client, it will say incorrect passcode. It will say incorrect passcode because I already this particular client was something. So I have to change here. Which you have to do the same thing for your own program. Over here, you can see I have to change this. The first one still participate. The third one is still your user ID, student ID. But this one, I'm going to change to Israel. And I'm going to make it again. So now I'm going to run this program. The first time I run this program, it will say successful. It will record everything saying that something. Wait a minute. You see that? I actually record. You see, I have a two time. The first time I have Israel, which is this time, and then I have a something. So essentially, whenever you run this program, it will not only tell you that this time you're successful, it will tell you all the previous time you have participated. So I modified the server code a little bit. So now the server will tell you your participation along the, so this list is keep building. So you know precisely which class you miss, which class you have participated from now on. Okay. So if I actually try to run the same program again, you see this time it will say the status is already registered because today is the first class is going to be Israel. The second class will be something else. So right now you can see that. So if you see either already registered or successful, that means you have done correctly. And then whenever you run this program, you can see which one has already registered. So, okay, for all of you, because the something is something which is I actually added after last class. So last class, you don't worry about that. For this class, you need to see that you have this Israel. Okay, and associated with your student ID. That means you have been correctly, successfully get the, okay, so I have been seeing, okay, okay, I see one of the students says incorrect passcode. So that means you didn't provide Israel, you provide something. Okay, so let me get back to where you need to change. Inside this EE1520 client program, which is you should download from the GitHub. And the rest of the code, you don't need to worry about that. But this piece of code, this is the key line under the try. The first argument need to be participate. The second one for this particular hour need to be Israel. And the third one is always your student ID. I actually might change it so you can provide the VName as well. So if you use VName, it's okay. But right now my server hasn't been configured to do that. I will change that by next time. You can actually provide your VName or student ID is up to you. Okay, so yeah, I'm actually seeing you guys are coming in. And then I think my ngrok server is still running. So, okay, so let me know if you have any question. I mean, we will be kind of graceful, meaning that if you have, okay, we have a two hand, Richard, can you help me to see what's the issue? I mean, if this hour you still don't get it during the break, I will help you. Okay, but you need to do that. If you cannot do it, really cannot do it. My purpose for doing this is two. Number one, make sure you come here. Number two, I want to make sure that you are familiar with the flow about programming. You're familiar with using GitHub. You're familiar with using Make. You're familiar with modify the code and such that to fulfill the purpose. And gradually you will learn all the detail. Okay. Any other question? I give you a few minutes and don't worry. Don't panic if you cannot get it to work. My responsibility is make sure everybody, at least today, will be able to submit the participation correctly. Okay. Okay, I give everybody a couple of minutes and then I'm going to talk about today's subject, which is the homework assignment number 1. Okay, while you are doing this, why don't you work on this for 1 minute? Let me get back. I want to get a USB drive and then I can talk about the things I want to talk about. Hey, Richard, I'm going back to my office just for 1 minute, and can you help the student take care of the participation? Okay. One second, I have to stop sharing to do 1 second. Hold on. I'm going to disconnect for 1 second. Sorry about that. I want to check one thing before I embarrass myself. It's fine. This one is fine. Okay, there is nothing in here I need to worry about, so I can share the screen. Okay, you guys are still working on that? Okay. I give you 2 more minutes and then we can. I mean, if you cannot get it to work, I will get it to work with you at the time. I'm still seeing a lot of incorrect passcode. If you see this, that means you haven't modified your code to modify the keyword something to Israel. We're expecting Israel right now. which means that you have to have a way. Okay, there's a few things. Let me actually write down what you need to do. Seems to me a lot of you haven't got it. Okay, this is what we did last time. You have to do all this. You have to install JSON RPC CPP. You have to install the EE1520 participation from GitHub, which is a zip file uncompressed, and then change directory. And then you have to modify EE1520 client.cpp, which is the correct passphrase. Today is Israel. And then you have to make the program, and then you have to run the program. Okay, it's for those of you who are unfamiliar with the process, that it looks a little bit complicated, but I want you to make sure you will feel comfortable doing all this. Okay, that's the get you familiar with how to do software development. Okay. All right. So let's Richard, after you finish helping the student, then we will get back to class, and then let's help other students during the break. Okay. I will make sure everybody get participation correctly. Okay. As long as you come here, don't worry about that. This is something which is part of the learning process I want you to do. Okay. Okay, I will keep the server running. Okay, that's it. Well, I'm going back. Hey, Richard, can we help him a little bit later? Because I want to get back to the class. Okay, so everybody listen here and don't work on whatever you're working on. We will give you time to work on that during the office hour. Okay. All right. I'm actually going to show you everything I'm going to provide is related to your homework assignment number 1. Can we do that a little bit later? Sorry about that. Thank you for helping others, but we need to come back. Okay, thank you. Sorry about that. Okay, let's listen up here. The tool I'm going to show you, look at the screen, is called DU. You can actually type this command called disk usage on your system. It basically show me all my program. You see, it's probably too fast. Okay, but I'm going to do this. I will go do du minus h2. Huh? What's that? du minus h minus 2. What's the depth level? Sorry about that. D, sorry, minus d2. D2 is still too much. I'm going to do a depth 1. Okay, so if you type the command du, this is called disk usage. I'm going to kill it because it tried to reach. So if you go back, when I type du minus h, you will see that I have a bunch of directory. One of the directory called Intel, one of the directory YS. I want to look for a bigger directory. Okay, I have a directory called IPYMB. This is related to Python. And you can see that this particular directory has about 148 gigabyte. Okay. So now let's actually look at my IPYNB. So go to CD IPYNB. Okay, then I'm going to do the same thing again. Okay, this is my directory. You can see that I have a directory called llama2, is 2.8 gigabyte, the 2.8 megabyte. And then one of the big one is this one, llama2 CPP. I have a file called llama2 CPP, which has about 36 gigabyte. Okay, that is on my disk. That's the largest directory. Okay, right now, assuming I want to do one thing. I want to send this file, send this whole directory to something else. So there is a very useful tool in Unix called tar. The facility tar is helping me to grab everything into one single file and then send it to something else. So I'm going to tar the LMCP. So what I'm going to do is the following. I use the command tar. I use the command zcvf, which is Z means compression, C means create or construct a tar file. V means verbal, so you can see the progress. F means is a file. So I do a tar zcvf, and then I'm going to create a file I call a llama2, llama dot, I will say llama EE1520 dot tar dot gz. Okay, this is the file format, the style about the file I'm going to create. And what I'm going to do is getting to llama CPP. So by the way, llama CPP is a llama implementation using C++. So I'm going to generate a file. You see that I'm actually start generating a file, and that is the large language model, the 16-bit large language model. It was created. I have a purpose to show you this, but don't panic if you see that why I'm doing llama. No, you're not doing llama. I'm just actually showing you an example, but it's actually being created right now. Yeah, it takes a while because that particular file is one of the biggest files. It's a 7 billion parameter model. Okay, so that's why that particular file is kind of big. One second, it should be done pretty soon. Okay, while it's being compressed, I want to actually show you my USB drive. My USB drive. Okay, so let's take a look at the USB drive. The drive here, if you do use my computer, it says get info. And this drive, it says how many megabytes gigabyte I have, 256 gigabyte. And the current file format is ext fat. Okay, so ext fat, let me, if you still remember that, but don't worry, I'm going to reformat this. I'm going to reformat this hard drive. Go to disk utility on my computer. In your computer, something may be different. And I'm going to click on this. I'm going to erase. When I erase, I'm going to generate this into what we call MS-DOS fast, which is FAT32. So I get rid of this file. So now I have a USB hard drive, which is a FAT32. I don't know if you remember what is FAT32, the difference between FAT32 versus ext-FAT, which we will see that in a moment. Okay, now I'm coming back to here. I want to actually check the status. It's being compressed, but you can see that I'm actually, can someone tell me how big is the file right now? It's being built. KB, megabyte, gigabyte. Right now, this is about 2 gigabyte. Okay, if you look at this is about 2 gigabyte. It's creating the file. but I want to, it's supposed to increasing because it's actually getting the Llama, the whole Llama project is supposed to be 140 gigabyte. My estimate, it has to be at least 10 gigabyte or something after compression, but probably not because okay, it's already 2.7, 2.8. I want to wait until the 3.2 gigabyte, then I'm going to do something. I'm not going to wait all the way finished. 2.9 right now. I believe it's still running, still compressing this large language model. The smallest large, okay, 3.1, 3.2, I'm almost there. So what I show you so far, three things. Number one, there is a command called du, so you can see the disk usage on your file. And the second thing is the what we call using tar file, so you can generate a large file. Okay, so now I think I have enough. So you see that I have a file which is pretty big, 3.5 gigabyte. So let's try to copy this file to my USB drive. So I haven't done this, so hopefully this will work as I expected. So I'm going to sfelix foo and go to IP YMB. So now I have this file, which is 3.7 gigabyte over here. Okay. What will happen? This one has 256 gigabyte, and this one has 3.97 gigabyte. So which one is bigger? The hard drive is bigger. It's the USB hard drive. So let's try to copy this, see what happens. Can someone tell me what's the issue? It says that the item Llama 2 EE1520 cannot be copied because it is too large for the format, for the file system format. Can someone explain to me why I will see this error message? Anybody have any idea why this is the case? Anyone? I promise you I will give you chocolate after the break. If you answered it wrong, that's okay. Nobody want to give a try? You want to give a try?
可是他的那个，就前某堂课有提到那个他的资料是用那个32。
Right.
所以他那个资料档案太大，他没办法自己。
Right. Thank you. I owe you 2 chocolate because number one, you're willing to answer. Number two, you get it correctly. Okay, that's good. Yeah. So let me tell you why this is important. I want you to see what's going on. Okay. So everything you learn from this class, you should be able to seeing that what's happening in your own life when you want to process data. I mean, by the way, the first time I encountered this issue is I was having a DVD movie. So I converted, I was very smart. I said, hey, I want to copy this DVD movie. I'm doing legally, by the way, legally, okay? Legally, okay, if you believe me. Okay, so legally, I want to copy the DVD movie to my hard disk, to my USB, so I can carry I can watch whatever I want. I don't have to carry the DVD because now the new computer doesn't have a DVD anymore, okay? Go to UC. So I realized the DVD movie is 4 gigabyte. And I cannot copy into a file that's actually the FAT32 because FAT32 is a 32-bit address. Remember, we talked about the memory box concept. So because of 32-bit, I'm actually in trouble. The largest one I can actually copy is 2 to the 32 because 32-bit means that it can only address at most 2 to the 32 byte. which is 2 to the 32 is 4 gigabyte. Actually, is wait a minute, 2 to the 32 is 4 gigabyte. Yes, it's 4 gigabytes. Is that right? Yeah, 4 gigabyte. So because 2 to the 30 is 1 gigabyte, 2 to the 40 is 2 to the 32 is 4 times 1 gigabyte. So anything that's more than 4 gigabyte, it cannot allow. That's why it's happening here, because we're creating something which is bigger than to the so just to let you know, there are two solutions I can deal with this problem. Number one, I can reformat my USB drive to ext FAT. So MS-DOS FAT is the 32 FAT, but ext FAT is 64 FAT. So I enlarge my file system to 2 to the 64, and such that I can deal with a huge movie. That's one way to do it. But the other way to do it is I want to teach you how to do this for your homework assignment number 1. Okay, is I have to break the file into smaller pieces. So I can store to a FAT32 file system, and then later I can actually kind of heal it back. So the homework assignment number 1 is called my break and my heal. So this is your homework assignment number 1, is essentially how do you split a file? Let me make it a little bit bigger. So how do you split a file into fixed size pieces and you can put them back together? Okay, this concept might sound very simple, but I will tell you later this quarter, this simple concept has a dramatic impact about a lot of things we're doing to learn about how to split and how to realize each of the chunk where they are and to put them back together. So this is a simple homework for your level, but I hope you learn well because there's a lot of depths into this. So let me first show you a demo. Let's see if I finish. I want to show you how to split and how to break. How to break and how to heal. Let me see. Do I finish this? Oh, it's still getting there. Okay, fine. Okay, now it's about 8 gigabyte. I'm going to actually copy it. Oh, by the way, in Unix, if you do pwd, I actually will see what's the path. What's the path? This is from /user/sfw/ipynb. So I'm going to, wait a minute, why I'm getting this? Okay, I'm going back to here. I'm going to cp /llama e. Okay, I'm going to copy this file here. Okay, I want to let them continue to do whatever they're doing, tar, but I want to copy a copy so I can do. Okay, so now you see that I have a file, which is llama, whatever, has about 9 gigabyte. And this file, by the way, I can, by the way, right now I can kill this. I don't need this anymore. 9 gigabyte is enough. Okay, I want to remove these files to save my space. Okay, so now I can go back. I have this file, and still this file is still too big. So I'm going to use my break program. So I'm going to make by the way, all this code I'm showing you is already on the GitHub of the EE1520. You should, from time to time, you should download, but this file should be there a while ago. I'm going to make -f, make file break heal. Okay, you can see that it generates a program called my break. It generates 4 programs. The first program is called my break.c, my heal.c, my diff.c, and it generates something called EE1520 break.c. I'm going to first show you my break and my heal. It has all the source code. So let's try to run this. If I do // my break, it says that if you type only / my break, it tell you that, hey, this one I need I hope you remember from EE1520, whatever, the first session, the last semester, the business about ARGC and ARGV, which is number of argument you need to pass into a program, and ARGV is an array that capture every single things you type in at the command line. So when I do my break like this, that means my ARGC is equal to 1 because there's only one argument. That's ARG means argument, C means count. So ARGC means you only have one argument. And this program I break, I expect 4 arguments. So I expect the name, my break, I expect which file I'm going to break, and what's the prefix I want to put in, and what's the chunk size. Because I'm going to split the file into multiple fixed size chunk. I want to know what's the size you want to put in. Okay, so I'm going to do this. I'm going to do my break. And the source is going to be llama. This is my source. That means the file, I try to break it. And the prefix, I call it maybe E15. I don't want to call E15. I call NCKU. That's fine. NCKU EE. Okay, that's the size. And then the chunk size is interesting. I have to specify something that's in kbyte. Okay, I kind of designed that the smallest chunk you can have must be 1 kbyte. Okay, but you can change that if you want to. So let me see. I want to make it simple, make each chunk 1 gigabyte. Okay, so let me see. What's 1 gigabyte? How many chunks? I hate this. I should know the answer. I keep forgetting the answer. So I know one gigabyte is 124 times 1024. Sorry. Okay, that's the number of chunks I want to have. 10,48578. 10,48578. Is that right? 1576. Okay, so that's the number of K in kbyte. By the way, it's in kbyte. So I have each of the chunk has about 1,048,576 kbyte, which is equivalent to 1 gigabyte. So I'm actually splitting this file about 8 gigabyte into multiple. So let's see. So it starts generating the chunk. The program my break is going to generate. You can do exactly the same thing. Watch the video and get. I'm expecting I'm getting about 9 chunks. So the first chunk is called NCKU EE00000, whatever. I'm splitting, just a moment. I need a faster computer. That's or faster hard disk. Or because my chunk is too big. Usually my chunk is 64 megabyte, like a Google file system, each chunk is 64 megabyte. I mean, the same concept is still being used in all the large file system that Google and Facebook are using. Okay, see, I have 9 chunks. I create 9 chunks, NCKUE from 001 to 008. Okay, not too surprised. Let's look at their size. If you do ls minus l NCKU star, you can see that is each of them is essentially 1 gigabyte. Okay, you see that the total file size, let me do ls minus l on the original file, which is llama. Llama is about whatever, 9.4 gigabytes, something like that in terms of the bytes. And then they split into 9 chunks. The first 8 chunk has exactly the fixed size of the 1 GB. And then the last chunk is the remaining. By the way, I should tell you that sometimes confusing. 1 KB is, sometimes we say 1K is 1,000. It's not really 1,000. It's 1024. 1K is 2 to the 10. So when I say 1K byte, it's really a little bit more than 1,000 byte. So when we say 1 GB is actually a little bit, not just a little bit, but somewhat bigger than one whatever 1 gigabyte. 1 gigabyte, what's the word? 1 billion? Yeah, 1 billion bytes is a little bit bigger than 1 billion. But let's calculate the math, because computer programming, we're so precise. So you must, if you take this number, you times another 1024, then you're actually getting exactly the number. So this number is 1024 times 1024 times 1024 is 10737411824. That's the precise number for 1 GB, 2 to the 30. So 2 to the 30, you can see that that number matches exactly how we count. So that's why we're very precise. We know that's actually 2 to the 30. And that's exactly how we split those into that. Okay, so now we have each of the bytes 1 GB. Now you can see what I can do. Now I can go back to look at my EE1520. What's EE1520? It must be, I put it in document. You look at here, you see this is all the byte. I mean, this is misleading. It's not 107 GB. It's really exactly 1 GB. So sometimes the file system, they're not computer scientists. They're not programmers, so they're imprecise. Okay, so I split. Now you can do what I can do. I actually copy all of them. Now they shouldn't complain. Now they should allow me to copy now 9.43. So essentially the trick I was playing is I split the large file into smaller chunks, and then I can put it on the same file system, which I cannot do that before. Okay, so that's what we're doing. Why it's doing now? I'm going to do the second part. I'm going to heal the back. Right. Remember, I carry this hard disk to on a trip to France, and in the middle of the night, I have nothing to do. I want to watch this movie called Llama 2. Okay, so let's try to see, how do I heal the back? So I have another program, which is also, you have the source code called myheal. If you type /myheal, and still it says that, okay, there's a bunch of argument. And now this argument has a little bit more. It says source, prefix, chunk size, and chunks. Okay, so now let me try to do that. I'm going to use my break to do this, because the first three argument is the same. So I will say myheal. And now I'm actually going to call this a little bit different. I call it copy. Okay, I want to copy a different file. So still NCKU, still this, but now I know I have a 9 chunks. Okay, I have a 9 chunks. So the break and heal, they have one little difference, is that when you heal, you have to tell my heal program that what's the how many chunks that you have. So I'm going to run this. So now my heal program is trying to put all these chunks back to its original format. So I break it, I heal it, I copy it. You can see that I'm a happy programmer. I can do whatever I want, regardless your file system format, regardless how big, how small your file. By the way, I can do this with one USB drive. I might have next time, assuming I don't have a 256 GB, but I have 256 1 GB USB. Okay, remember, this might happen, right? I don't have a one USB with 256 GB. I might have 256 USB hard drive. Each of them is 1 GB. And I can still do this. Okay, I can carry a lot of, okay, now you see I actually put it back. My heal, my break, my heel, I put it back, and I generate a file. Let me actually do a ls minus l, llama, and star. You can see that I actually generate two files. One file, this file was my original file that before the split. I actually break the first file into 9 different chunks. And I use the same 9 different chunks. I actually heal it back into this. But at least from the number of byte, they're identical. Number of byte. But I'm not satisfied with this. You could generating the same number of byte and give me a file which is a junk, right? You can actually just generate random file with that, and I don't believe that. So I have to use a program to compare these two to make sure they're actually the same. So one of the facility called diff. Diff is a facility in Unix tell you the difference between these two files. So let me use diff for this one. Tar, and then llama. This is, I have to do a copy. So it might give you say that those are binary file. Are you sure you want to do something? But I'm doing a diff. You see, I'm doing a diff. It take a while because it need to scan through 9 point something gigabyte in order to see the difference between these two. So if it doesn't say anything, that means so far everything is identical. It basically doing byte by byte comparison. And in the same directory, I have another program called mydiff. I basically, whenever you use a tool, diff, you can actually think about, okay, it's not that hard to implement your own. So I have the source code called mydiff is, okay, so there is no difference over here. That means those two files are the same. Let me actually show you an example. Sometime you will see something is different. Okay, let me do a Control X, Control C. I mean, for example, you see I have a 2 client program here, right? One is EE1520 client.cpp. One is a EE1520 client.cpp tilde. The reason I have that tilde file is because my editor always kept the previous version. So I can do a diff EE1520 client.cpp and then EE1520 client.cpp tilde. So if I compare this two, I want to see what did I just change? Okay, so you have a file called E15 client.cpp. I want to know what I just changed or what somebody else changed so I can actually know. If you do a tilde, you see that it actually record the difference. You see, it's very smart. It says that the difference between these two files is what? The passcode, right? I changed it earlier today from something to Israel. Okay, so you see that this diff2 is very useful. It actually keeps helping you to capture what you did. So diff is essentially showing you the difference between two files that you provided. I mean, sometimes, of course, you provide two unrelated files. There's a huge number of difference. This is essentially the whole algorithm called editing distance, about how do you calculate the difference between two pieces of information. And this is, so it's easy when your difference are nothing or very little, so it can show you the result. But if the two files complicated, it show you very complicated result as well. Okay, so that's good. So I want to tell you that this program, I hope I convince you, using diff, using my break, my heal, I accomplished some purpose. Okay, so I'm going to stop here. And during the break, please come to check with me regarding the participation. Okay, I will stop here. 1 second.